Today we are talking about the new race mode that DJI have introduced with O4. Now this is a technical deep dive on race mode. We're going to talk about what it is. We're going to take a look at it on the spectrum analyzer and compare it to what we had before, but also compare it to the likes of HD0 and analog. We're going to talk about latency and show you some of the results of my testing. We're also going to show a little bit of penetration testing that I've done on the bench as well. And the idea of this video is to give either someone who wants to use race mode all of the information they need, but also if you're a race director or someone who wants to integrate race mode into their system with DJI, this will give you the technical information that you need to understand so it doesn't cause problems with other systems. In the end, what we're going to do is try and cover as much about race mode as we can, so let's get on with it. So to start, now DJI have introduced a new race mode with O4. This new race mode is not available on the O3 air units. It is not available on any of the other DJI systems. It is only on the O4 Pro and the O4 Lite air unit. This new mode is also only compatible with the latest DJI goggles, which is the DJI Goggles 3 and the DJI Goggles N3. Whilst you can use both O4 air units on the Goggles 2 and Integra, the Goggles 2 and Integra do not support race mode. It is only the new goggles that support race mode. Now, the benefits of this race mode are as follows. Rather than the system working like it did in the past, where you have big, large video carriers on the 5.8 gigs band, you then have your goggles telemetry carriers, but none of that can form into any of the usual channel allocation. Race mode, number one, allocates the channels the same as race band, so you now get R1 to R8 channels. Number two, it actually aligns the telemetry from the goggles onto the same frequency as the video carrier. So rather than spreading itself across the whole band, it is much cleaner on the band compared to the other versions. It also improves latency, and it does depend on which goggle and ear unit you're using. So for instance, on Goggles 3, when using the O4 Pro, latency is as low as 15 milliseconds. However, when using the O4 Lite on the Goggles 3, latency is around 20 milliseconds. There is a roughly 5 milliseconds increase in latency between the Lite ear unit and the Pro. This is a little bit annoying because the reality is the Lite ear unit is the one by far most people are going to want to install in a race system. Now, when it comes to the choice of goggles, there are obviously differences between these two. The N3 is a budget goggle. It is a single LCD display that is limited to 60 Hertz, whereas your Goggles 3 has your OLED displays capable of 100 Hertz. As a result of that, while both of these goggles will work with race mode, you're only going to get that low latency 15 milliseconds on the Goggles 3 with regards to the Pro ear unit, or 20 milliseconds on the Lite. You are not going to be able to get that low on these. The latency's a little bit higher. Now, with regards to using the DJI Spectator mode, you can absolutely use that between these goggles. Unfortunately, though, you cannot spectate to an older set of goggles, even in race mode. You would have to be using Goggles 3 or Goggles N3. Now, one other thing quickly to mention on goggles is battery, because one of the big limitations pilots may have for this is, I don't like this, I want to use an external battery. Now, you can use these goggles whilst powering them off USB. However, you can't do that if you're using Cosmos Streamer. I, though, do have a solution for this, and I have a separate video where you can replace the battery on the back with this with an XT60 input, allowing you to power these completely independently of that battery. You can use your own LiPo. I'm going to put a link to that video in the description, and that's going to suit people who want to use it for the full day. Now, with regards to the technical aspects around this, as I've said already, race mode, first of all, aligns onto the raceband channels. It doesn't, though, change the overall core behavior of the DJI system in the sense of it is still a two-way system. Your goggles will transmit towards your ear unit for the telemetry, and your ear unit will transmit back to your goggles. What is good though is that DJI have in race mode aligned this to keep them all on the same frequency. Now when it comes to using race mode, it's fairly easy to turn on, but there are a few little things you need to be aware of. So if we go into the menu, go down to transmission, under here we have our normal operating mode which we're in now, and then we have an option for race mode. Now if I turn this on, this will enable the race mode. It will push us into manual channel selection. It will also limit the system to 1080p 100 frames a second. That is the only options that are available with regards to the DVR recording. You can still record on the DVR, but you can see it is limited us to 1080p 100 in 4:3 as well. You cannot use 16:9, and that is with the wide camera field of view, but you can put it in to normal as well. With regards to the settings, obviously we have our channel settings. So here you can see it gives us R1 through to R8, and it does show the frequency allocation next to it as well. We also then have bandwidth options. Now as default, it will choose 20 megahertz. That's what allows you to have the correct channel spacing, but you can actually kick it into 40 megahertz if you wanted to, but this would not be advised for anyone flying around anyone else. It's going to use twice the bandwidth and it's going to cause problems. We also, alongside the channel selection, also have some power options available in race mode as well. So for instance, if we go into the power settings, we can manually choose the power output we want. So we can set 25 milliwatts. And DJI have also included a nice fine-tuning option for the power output as well. So if your race director did want to check it and say, hey, we think your ear unit's transmitting a little bit too much, you can actually adjust that here, and that will increase or reduce the power output from the power level that you have set. What you can't do is when in 1200 milliwatts go above 1200, but you can actually tune down. But from a 25 milliwatts perspective, it will allow you to tune it to get it to the right spot. You do still have your broadcast and your focus mode options available in race mode as well, but pretty much everything else is exactly the same. With regards to the bitrate settings, you'll get 20 megabits a second in the 20 megahertz mode, and if we then just pop down and shove it into that 40 megahertz carrier, not that you would use it, but we will stick it into it, you can see you're getting 40 megabits a second on that, but the 20 megahertz, 20 megabits is the one that everyone's going to want to use. Now, the one big question everyone will have with race mode is it still variable latency? And the answer to that is yes. The overall inherent behavior of the link hasn't changed. It is not like HD0, which is a fixed latency. It is still DJI. It is still a variable latency system that will prioritize image quality over latency, but what DJI have been able to do is reduce that latency. What we don't know yet, and it's going to take a bit of time to fully understand this, is the behavior of that latency compared to the normal mode. Does it try to hang on to the low latency longer than it did in the normal mode? It will take months for us to fully understand this. It isn't information, unfortunately, that DJI publish. Now, I am in the process of doing all of my latency testing on DJI O4. However, I have got the results of the O4 and O4 Pro ear units when used in race mode on the Goggles 3. Now, here you can see on the left-hand side, we've got the O4 Pro in race mode. The first pixel result that I've seen lowest is 17 milliseconds, with the average first pixel coming in at 18 milliseconds and the full frame coming in at 27. Whilst I haven't quite seen that 15 milliseconds that DJI talk about in the spec, I do think it's genuine. There are run-to-run variances, and it can sometimes take a lot of different runs before I will see the absolute lowest level. Here and now, the lowest that I've seen is 17 milliseconds. It's only 2 milliseconds off what DJI are saying, so I'm comfortable with the numbers that they have said. But take into account, those numbers are the lowest first pixel and not the full frame latency, of which that is 27. When comparing the O4 standard or the Lite on the Goggles 3 in race mode, you can see we do have that 5 millisecond increase. We jump from 27 milliseconds of full frame to 32 milliseconds of full frame. It is a shame that the Lite does have this increased latency over the Pro. The Lite is the perfect ear unit to have in a race environment, yet it has the highest latency of the two. Then, just comparing that back to the original modes, the standard modes, so O4 Pro in 1080p 100, you can see we've got 25 milliseconds to the first pixel, and then 36 milliseconds to the full frame, and then on the Lite, 30 milliseconds, and then 40 milliseconds. There is no question that the new race mode reduces latency. What's quite interesting, though, is if you look at these latency numbers and compare them to what we had on the V2 system, on the Vista or the original ear unit, race mode latency numbers are actually very much the same. Basically, with race mode on O4, DJI have given us back what they took away in O3, which was the low latency mode that we had on the original DJI FPV system. Now, looking at where this new O4 race mode lands compared to the other systems, HD0 and Avatar HD, the truth is, whilst DJI have improved things, there still is no comparison compared to HD0, especially in the Nano 90 setup. If you look here, you can see whilst DJI have got it basically the same, as I said earlier, as the V2 goggles in 120 frames low latency mode, HD0 is still a country mile ahead. Their first pixel latency with the Nano 90 camera is low as 2 milliseconds, full frame 14 milliseconds. That full frame is lower than the first pixel latency even on DJI O4 race mode. And then at the end, we've got the Avatar HD numbers there as well. Remember, also, HD0 is fixed latency, not variable latency, like DJI and Avatar HD. So whilst DJI have improved things, there is a long way to go before they even get near to what HD0 offer. Okay, now just to show you this on the spectrum analyzer and how race mode compares to the normal operating mode, which we are in now. Now, this normal mode is what O3 behaved like, and it is the same on O4. You can see here, we've got our large video carrier. That is roughly 55 megahertz. So that is the 60 megahertz carrier offering up to 60 megabits a second. And you can see all these other carriers jumping around the band. These are the telemetry carriers from the goggles. So if I just lift the goggles and move it closer to the analyzer, you can see that they've got bigger. And if I move it away further behind me, you can see they're getting smaller. Now, this is what causes the problems when using DJI as it is today. However, if we now switch into race mode, and we will enable that, the first thing you will see is instantly the band cleans up. The goggles carrier link has now also shifted on top of the video, and there is a dramatic difference in how this system behaves in race mode with regards to how much RF is putting over the carrier. So now we've got our video carrier, which is 20 megahertz in size because we're in the 20 megahertz mode. You can see our goggles carrier there in the middle. If I just take my goggles off and move it closer, you will see that carrier start to appear above the video there. If we now measure the width of that carrier, 5 megahertz width. So the goggles carrier has reduced dramatically. You can see that there. And if I move the goggles further away, you can see it reduces. But the important thing to understand is whilst the goggles are still transmitting, they are transmitting a much narrower signal, but on top of the same frequency as the video, leaving the rest of the band completely clear, meaning that you should be able to fly it with DJI, other systems, you can fly it with HD0, and you can fly it with analog. Now, you are still going to have an effect of these goggles transmitting, so you do not want to be directly on top of someone. You do want a little bit of spacing, but it shouldn't need to be a lot. As I've shown here, if I just pop this up, you can see there that goggles carrier is very noticeable. There it is. There we go. That goggles carrier is very noticeable once you get it on top of it, but it is still much smaller than we had seen before. Now, if I just switch back to normal mode, just to give you that view, boom, you can see it is instantly jumped back into that normal mode. Whilst we could put it in a smaller carrier mode if we wanted to, it still would have all of those goggles telemetry carriers transmitting all around it. So race mode really does make a dramatic difference. Just to show you what 3 systems look like next to each other on the spectrum analyzer, we're going to go for analog on R1, HD0 on R2, and DJI O4 on R3. So we're going to power up analog first of all. You will see that appear on the spectrum analyzer. You can see that traditional peak of a carrier. We are quite close here, so it's not going to quite look the same as it would at a bit of distance, but that's taking up roughly 20 megahertz of spacing at the bottom of the carrier. We're then on R2 going to go for HD0, so let's just power him up. There we go, and you should see any second now HD0 kick in. Boom, there it is. Again, this is in the normal operating mode, but it's exactly the same in the Nano 90 mode. We've got our carrier, which is taking up a little bit over. HD0 usually says 18 to 20 megahertz. You can see we've got 23 megahertz there, but that's on R2. And then let's go for O4 on R3. Let's just wait for it, and it'll kick in once it connects to the goggles. Boom. There we go. You can see the signal is there. Now, just ignore the levels. That isn't relevant here right now because they're all in slightly different positions on the bench. But then here you can see DJI kick in. It actually looks like a little bit of a smaller carrier than HD0 at this point. You can see HD0 there. But what you can see is each of the systems is not really causing any interference on the band. They are all sitting next to each other, not interfering with each other from an RF perspective. As I've shown, the goggles do transmit a telemetry link back to the ear units. However, it is worth understanding this point. When your ear side is powered down, so your ear units are turned off, your goggles do not transmit. There is no power on them at the moment. They're turned off. If we just power them on, we will just wait for them to kick in. The ear unit is turned off, so it won't connect. So the goggles will basically be in a standby mode. We'll just watch on the spectrum analyzer. I'll just wait for them to kick in, and I'll tell you when they're done on my side. You get a very brief something on the display, and that's it. You can see that we're clear. If I look at 5700, if we go up the band, there is no transmission from these goggles at all when static, so there should be no issues using these around other pilots. About the only thing to watch is I have seen there's a bit of a quick band scan when you first power the ear unit up and it connects, but as I have said already, it will connect and it will jump straight onto the last channel used. But with regards to walking around with these goggles powered on, there should be no issues at all. What you wouldn't want to do is put them right up against someone else, because there's always going to be some form of EMI, but overall from an RF transmission perspective, they're basically dead. Now, one quirk I have found, though, in all of the RF behavior is what happens when you power up the ear unit. As I've said already, the goggles do not transmit when the ear unit is powered down. However, when you do power up the ear unit, there appears to be a bit of a band scan where it chucks a couple of carriers onto some specific frequencies before jumping onto the last channel used. Here, I'm going to show you what it does on power up. You can see these carriers appear. This is between 5730 and 5800, and you can see it jumps around a little bit before settling on the main carrier. What you're seeing here is slowed down. I will do it again in real time so you can see it. It is very, very quick, but it is something to take into account. So what I would suggest is, whilst there should be no problems walking around with the goggles on when other pilots are flying, I would not power up O4 whilst other pilots are in the air. Now, just to give you a quick view of the effect each system will have over the other, I have 3 ear units lined up about half a meter apart. And what we're going to do is power them up one at a time. We have got analog on first of all. That's what you're seeing here. We're then going to power on HD0. So you can see me doing that in front of the camera. It'll take a second or so for the HD0 to kick in, and then you will see that appear on the display. There we go. And then we will power on DJI O4 to show you the difference in how they behave. On the bench, the goggles are all about a foot apart at this point next to each other as well, so it'll give you an indication of the effect that has too. Here I'm plugging in O4 and the thumbs up is that it's got power. You will see a bit of interference appear on HD0 as the ear unit boots, but it does settle down. Then you can see the O4 recording kick in. Overall, analog doesn't look affected. There is a few more sparkles on HD0. Okay, so at this point I have all 3 systems on. They're about 2 feet apart. The goggles are here, the analog, the HD0 and the DJI. All systems are recording, so what you're seeing now is the actual feed from them. Now, obviously, as the DJI goggle does transmit, if I move this closer to the HD0 goggle, it is likely to have an effect. If I move this closer to the analog goggle now, it is likely to have an effect. But the truth is, with good separation, I'm just going to place these over there. They should all behave nicely, but obviously there's going to be a difference in this as you actually fly. Now, something I just want to mention on this whole subject around using DJI with other systems. In the past, it was absolutely DJI's fault, some of the problems they've caused. But today in race mode, DJI have done everything they can. The goggles only transmit on the same frequency as the video when in race mode. The channels are very clean. They're very tidy. There is no out of channel interference. O4 in race mode is perfect with regards to its RF behavior. Anyone who uses this with other systems and those systems get interference, that is not DJI's fault now. It is the fault of the receiving equipment on those systems, because DJI have created a mode that does exactly the same as HD0 analog. It only transmits on the channel. The only difference being that the DJI goggles do transmit. Now, DJI can't stop that because their system is a 2-way variable latency system, but you are going to be battling interference on systems like HD0 and analog simply because these goggles are designed to have lots of amplification, especially HD0, to try and pick up as much of the signal as it can. But that even being near anything else that transmits on the same band may cause a problem, and that's what we're seeing here. My point I sort of wanted to make in this is the days of blaming DJI with race mode are over, and now it's over to the other systems on how they behave with cross-channel interference. Now, with regards to using it with lap timers and others, I can't give you any definitive answers around this right now, but what I can say is early reports are good. It seems to be fine. It should basically work no different in that regard to the likes of HD0 because they're both wideband OFDM style carriers, so as a result of that, the timing system should be able to pick it up. What I would say is you do want a bit of separation between the goggles and the aircraft with regards to that. You wouldn't want to be sitting directly on top of a race timer because remember, your goggles are transmitting. But overall, what I would say is that it shouldn't be a problem. We'll have to wait and see, though, for all of the manufacturers to come out with their information. Now, when it comes to sharing the video and video out and getting it into an event, this is where things get a little bit more complex with DJI. HD0 is by far the best in this regard. Not only do the goggles have HDMI output, but HD0 have their fantastic event VRX that not only picks up HD0, but it seamlessly picks up analog as well, automatically switching between it without people having to mess around. Unfortunately, that event VRX cannot pick up DJI O4, so if you want video out on this, there are a few options, but they are limited compared to the likes of HD0 and Analog. The first way you could get video out on these goggles is simply connecting it to a smartphone or tablet via USB. You can, on the Goggles 3, use wireless streaming as well, but that would not be advised in a race environment. The second way is to use Cosmos Streamer. Now, Cosmos Streamer allows you to get video out from the USB port on the bottom of the goggles and then convert that into HDMI. Cosmos Streamer have their own device you can use, or you can install the software with a license on the likes of a Raspberry Pi, and this is fully compatible with the DJI Goggles 3, the Goggles N3, and both ear units. The only thing to take into account is you would need to understand the licensing around Cosmos Streamer, and you would need one device per goggle, so you would need to have either the pilot with his own device or have pre-set up devices, but I'm not exactly sure how the licensing would work on that. You would need to speak to Cosmos Streamer. Now, there is a bit more of a DIY way if you didn't want to pay the likes of the Cosmos Streamer license. You could use a Raspberry Pi with Android installed and try and install the DJI Fly app and stream to that, but you won't remotely have the functionality that Cosmos Streamer gives, so Cosmos Streamer is by far the best option. Now, when it comes to race mode and its RF behavior, it's going to take a bit of time for us to fully get to grips with any differences that there may be. However, that doesn't mean that we can't do some tests, and that's what I've been doing over the last few days. Now, when it comes to doing these tests, I always do it in a strict test setup that I have a fixed point VTX on the bench, usually looking at a video playing on YouTube, and then I go wandering with the goggles, and that allows me to move myself into very specific positions and test the different behaviors between the modes. Now, here in this bench testing on the left, we have it in normal mode, and on the right, we have it in race mode. This was done in identical RF settings other than race mode, so both in 20 megahertz carriers, both at fixed 50 milliwatts of RF output. The reason I chose 50 over 25 is because it allowed me to see things in a little bit more detail, and both basically exactly the same, apart from one is in normal mode and one is in race mode. Now, if I just hop back to the start of these videos, I can talk you through the differences that I'm seeing. Now, on these tests, I've got myself to virtually the edge of signal. I am going to take it a step further in a minute. On the left, you can see normal mode is hovering around 2 or 3 megabits a second. And on the right, we have race mode, which is sitting at about 1 megabits a second. I was definitely noticing a little worse performance in race mode than I was in the standard mode. I then moved to the point of basically signal loss. On the left, you can see here we're at 1 megabit on the standard mode and basically hovering between 1 and 0 on the right in race mode. What you will see is both start to break up, but race mode does break up a little bit more than the standard mode, but I will be honest, it is very, very close. I was expecting a much bigger difference in performance between the two different modes than I'm seeing, and it is very, very similar. Now, as I have said, a lot more testing is going to be needed to really understand this. However, so far, from what I've seen, whilst race mode does perform a little bit worse with regards to penetration than normal mode, it is extremely close. It's far closer than I was personally expecting. I was absolutely expecting race mode to be performing worse than standard mode simply because of the change in the RF behavior, but it isn't a great difference from what I've seen so far. So what I can say is there shouldn't be any dramatic night and day differences between the two. It is looking a lot more subtle than even I was expecting. Now, one last thing I just want to mention on race mode is around the DJI remote controller. It works exactly the same in race mode as it does the normal mode. For those who don't know, there's a bit of a big change with O4 in how the remote controller works. The remote no longer communicates directly with the O4 ear unit. Instead, the remote communicates with the goggles, and that then sends that signal over to the ear unit via the goggles telemetry link. Both normal and S-Bus fast mode works absolutely fine in race mode. It's exactly the same as it is in normal mode, and whilst you don't want to use this, if you absolutely did want to, it does work. That is everything we know about race mode today. To wrap all of this up into a nutshell, DJI have created a mode that cleans up the RF behavior of the DJI O4 system compared to O3. Really though, this mode is giving us back what DJI took away with O3, very similar latency to what we had on the V2 goggles in low latency mode, much better RF behavior. You've got manual controls back, manual RF power settings, and whilst DJI are wrapping this up in a new mode, the truth is they're giving us back many of the things that they took away in O3. What should be congratulated though is the fact that DJI have massively improved its RF behavior around how it behaves with other systems in race mode. It aligns to the race band channels, it moves the goggles telemetry onto the same frequency, and there is no technical reason this now will cause any problems with other systems other than the fact that the goggles do transmit, and those other systems may struggle a bit with that fact if in close proximity. Race mode is definitely something I think DJI have done a really nice job on. It's a great feature in O4, and as you've seen from some of the early testing on the penetration performance, there really is very few downsides. Yes, it limits the modes that are available, so you're limited to 1080p 100 frames a second, but you are getting lower latency as a result. About the only complaint that I do have with race mode is the fact that the standard or light ear unit has higher latency than the Pro. You still have this silly situation that the standard ear unit is by far the one that is going to be put into most frames, yet you have a penalty as a result of using that. DJI, I would love to see a software update or something to allow us to get that same low latency on the standard ear unit as you do on the Pro. Now, I hope this video has been helpful. I hope it's been interesting. Please do let me know what you think below. If you have any questions that I haven't answered, please do put them below as well. And finally, I just want to say, if you have found this video interesting, you'd like to support the channel to allow me to keep doing this in-depth kind of testing, please do consider checking out the link to my Patreon as well as buy me a coffee. It is only through the support of my patrons I'm able to keep making content on this channel. And if you'd like to support us to allow us to keep making content in the future, please do consider checking it out. And when I say a massive thank you to all of my Patreons, we would not be able to do this without your support. I want to say a huge thank you to every single person who has donated. Now, that's it from me on this one. Stay safe, and I will speak to you soon.